Now we have a problem here where we try to find out the density of a metal wire, but this time it includes its absolute uncertainty. When we have a problem like this, we usually do it in two steps. The first one is we try to solve for solely just the density. So we solve using the density equation. Then afterwards, we deal with its absolute uncertainty. All right, so let's start first when trying to find out what's the density. So that's rho, so equals to mass over volume. The mass is given already, but the volume is not yet given, although we are given an expression to solve for volume, and we have the necessary quantities for us to use so that we can solve for volume. So let's just proceed directly to it. So remember, when you're solving for this one, always use SI units. So we start with of mass 0.225 times 10 to the negative 3 all over. Use this equation, this one. So that's pi 0.38 times 10 to the negative 3 squared multiplied by 25 times 10 to the negative 2 all over 4. Okay, solve this and you will get 7940. Round off. So you'll have kilogram per cubic meter. Okay, so this is now your value for your density. Now, to solve for the absolute uncertainty, remember that when you're dealing with multiplication and division, what we do is we don't add the absolute uncertainty of every single quantity that you deal with, but we add their percentage uncertainty. There's actually a way in order for you to solve it, and usually we write it down this way. So delta rho over rho equals to delta m over m plus, since we don't have volume, we have the equation for volume. Use that. So 2 coming from the exponent of the d. So that's delta d over d. So 2 now of the exponent becomes a coefficient. So you need to multiply this by 2 plus L, delta L over L. The delta value is your absolute uncertainty, and the m, d, and L in the rho is your magnitude of that specific quantity. So here you'll have now delta rho over 7940. Delta m, that gives you 0.001 all over 0.225 plus 2 multiplied by 0.01 over 0.38 plus 0.1 over 25. Okay? So solving all of this so that we can get this delta rho, you'll get, okay, let me just solve it real quick. 0.001 all over 0.225 plus 2 times 0.01 over 0.38, okay, plus 0.1 over 25, okay, multiplied by 7940. You'll get 485 as your absolute uncertainty. Now, take note that when you're trying to write down your full answer for magnitudes together with absolute uncertainties, there's a certain rule that we follow, right? For the absolute uncertainty, it should just be under 1 sig fig, and the number of decimal place that you have in your absolute uncertainty should be the same for your value for your density. So in this case, we have 7940 for density and 485 for your absolute uncertainty. Remember, you need to have only one significant figure. So what we're going to do here is we're just going to adjust the value of your absolute uncertainty. So if we're trying to move it 3 times here, you will now get 0.5, right? 0.5 times 10 to the third. If we're going to do it the same with this one, we'll move it like 3 decimal place. You will now have 7.9 times 10 to the third. So your final value now will be 7.9 plus minus 0.5 times 10 to the third. This is now your final answer.